sitting down, ready to go, we may as well get started. I'm just going to give a very brief introduction, then hand over to Rob to moderate this session. Rob Herring, I think you all know, is part of Octo. He's recently been doing a lot of work on Project ARA. There is actually a link between Project ARA and 96Boards in that the point about Project ARA is you can have different APs, different AP modules, and one of the AP modules in the existing ARA project is NVIDIA, who are not a Linaro member, and they have a development board called Jetson, which some of you may have seen, which is a V7 Tegra development board. And that's being used by the ARA developers as a development platform. The other AP that's being used is Marvell. And Marvell have announced that they are building a development board for ARA for Google for that. And that's basically being built to the 96Boards spec. So there is a link there, and everything should be coming together, which is quite interesting. So this session's about software, and it was kind of originally, I think David was going to run it. And the title of the session went along the lines of, what does it take in terms of software to be successful at building and delivering these kinds of boards? Now, if you're only dealing with one SoC, that becomes a relatively easy question, right? One of the interesting challenges about what we're doing here is we're saying we want to come up with a plan and a software strategy that works across multiple SoCs. And so we've had to be very careful in the specification about what does it actually take in software terms to be 96Boards compliant. And I don't think we've got an answer that we don't necessarily know what the right answer is today, which is why we'd like input from you. As I just said to somebody, one of the easiest answers in terms of open source is, well, of course, I want everything open source. The more open source software I have, the better, and that's the end of the answer. But the reality is that every SoC vendor has completely different bootloader strategies. Every SoC vendor has, particularly in the mobile space, has huge numbers of lines of code that are proprietary additions to an upstream kernel. And so how do we deal with that? So very briefly, what we're doing initially for compliance is we're saying, look, the goal is to have upstream support for your board. We recognize that when you're bringing out a new SoC, or it's a mobile SoC that's never been anywhere near an upstream kernel, you've got a way to go, right? You can't instantly create something upstream. So what are the requirements? Well, what we're saying to start with is either the vendor must have a published source tree, for one. It can either be a vendor-supported Android, or it can be a mainline or tip Debian or Ubuntu build, or we expect we'll probably also enable Fedora, or you must have an open embedded Yocto implementation that again is upstream or close to upstream. Or you can have a Linaro stable kernel implementation. Linaro is only going to, or the 96Boards community, is only going to kind of maintain upstream support. So if you as a vendor want to participate in 96Boards program, typically what happens is you as an SoC vendor probably aren't the board vendor, right? You're probably not building the board yourself. You have a contract manufacturer, or you have a manufacturing partner, or you have a third-party company who's just interested in this market segment who buys your SoCs and builds boards and sells them to the community. But nevertheless, in order to be 96Boards compliant and to enable us to support the community, we're going to need and we're requiring second-level support from the SoC vendor. So if you've got a binary blob for your graphics or for your networking, and the Linux kernel moves forward and the binary blob's broken, we need your commitment on day one that you're going to provide us support to be able to upgrade that so that we can provide those binary blobs to the community.
For how long?
For as long as you participate in the program, right? And participating in the program requires an annual fee which is relatively modest compared to our other memberships, which are reassuringly expensive. So a relatively modest annual payment for membership of Linaro Community Group, and also there's a small royalty paid per board which goes towards the costs of building the website, managing the community, and so on. So the more boards you sell, the more you pay, and the more resources we can put into this whole program. Hey, I haven't got to the end of my introduction. You can't start asking questions yet. These guys are going to answer the questions, not me.
So can a 96 board label get revoked?
Yes, it could, theoretically. I mean, it would be very difficult, but theoretically.
You said if they don't update the kernel or update their blob, so the kernel moves along, they're not updating the blob, so when they launch they were compatible, but a year on, it's a worthless board. What then?
Yeah, but if it's a worthless board, nobody's going to be buying it.
But it still has the 96 board stamp.
Right, but it
Still approved when I bought it.
yes, it was approved when you bought it. The reality is, I mean, I think if anybody's going to invest in this program, either they're going to succeed and they're going to want to continue, or they're going to fail and nobody's going to care, right? And the market will decide. But I think that the challenge then comes of what if, this is the long tail problem, right, which is now starting to wear business, the business aspects of building boards and selling them into products and so on, which isn't really about this session. We can take that offline. So what I really want to focus this session is on the software. So the final piece of introduction is what are we providing today on the high keyboard, because that's our kind of initial reference. And the goal here is to provide a full source tree for the Debian release that you saw today.
I thought you said included in Debian.
Sorry?
Did you say included in Debian?
Included in Debian.
Like Debian already has a kernel.
So Debian has ARM v8 now support, thanks to all of the work that was done by Steve and others on the server farm. The Debian kernel will there are a small number of patches to make the mainline kernel boot, even to UART. Obviously, if you then want to have things like Wi-Fi and graphics, and there's a driver for the DSI to HDMI, you need a set of patches to do that, right?
So it's not full source tree for Debian,
No.
it's the kernel source, the TI special sauce for Bluetooth, and I think that's it. That's the full source tree, not full source tree for Debian.
Yeah, we're not forking Debian. Right?
No. I was thinking the other way around. That I thought what you said earlier was that all the patches that are still required would be merged to Debian before they get into mainline. If mainline is too hard.
That would be okay if your board runs a Debian kernel. That's the other way
You,
around.
you could do that.
I thought you said
No, I
that
didn't.
it was required for
No.
that would let you get
Debian
into
would not take it.
Debian.
We don't
Yeah.
take non-mainline kernels because it's too much aggravation.
Yeah.
We just say no. Unless someone really promises to maintain it for 5 years or whatever, then it's possible.
Yeah.
But basically, we resist it really hard.
Yeah.
Just because of the hassles.
So before, hold all your thoughts, because I know there's a bunch of questions coming. I just want to finish the introduction, then hand over to Rob, and he can answer the questions. So that was, yeah, keep going, George. So that's on the kernel side. And we're also going to be providing a AOSP build on top of a 318 initially, but hopefully 319 and 320 soon, kernel. That will give you a AOSP lollipop on top of a mainline kernel. And then depending on the vendor requirements, we may also support the current production version of Android, which would be a 310 kernel, subject to vendor support. Then bootloader is interesting. The goal on this board, hopefully by the end of the week, is to provide a fully accessible source tree that covers ARM-trusted firmware, which of course is itself open source, UEFI with fast boot capability, and then the goal is to put things like OPTEE, the trust zone implementation, and also make that available as soon as the security working group can get that installed. And the goal really is to use these boards as references for all of the work and projects that Linaro does, and also that the rest of the community does, right? So the rest of the community is very welcome to put software onto these boards. We'll enable that on the community forums. It's just that we, in the 96Boards community, will help the community manage third-party software, but we obviously can't support every distribution out there or every piece of software that somebody's going to put on the boards.
What's the target audience for community?
What's the target audience for community? Define the question better.
You keep saying community,
Okay.
and everything
So,
that word means what you think it means.
I think I know what I think it means. I think I know what I think it means. I may not think it, oh, never mind. So, the idea of the community program, as we mean it in 96Boards, is that this is an open website, 96boards.org, that anybody can participate in terms of particularly the forums. We in Linaro, under the 96Boards brand, will moderate that forum, right? We hope that people will contribute, and we will contribute knowledge and information on that forum. We expect developers who use these boards, whether they're using one of our pieces of software that we provide builds for, or they're doing something completely different. So hypothetically, somebody may get Windows up on a board, somebody may try and put something else up on the board, right? They'll presumably bring a community of people who know what they're doing along with them, and we'll support it best we can, given the constraints that we have in terms of our own funding resources. But the idea is to make this open to everybody, and also we expect that the distribution channels, you saw Avnet and Arrow this morning, they have their own support teams that also work in on these kind of boards. And we expect everybody to continue to participate in this one central place.
I'm going to hand over to you.
Thank you.
So,
Far away.
is SOC documentation part of the acceptance criteria here?
Dang. So there is a strong recommendation that SOC documentation is provided. There is a requirement in the compliance spec that sufficient SOC documentation is provided to enable software developers to program the functionality of the board. Now, if you look at most modern SOC vendors, some are really good at completely freely publishing specs. So TI is a good example. If you can go out on the web and get specs for pretty much every TI ARM SOC that are literally, I think the OMAP 4 one is 1,500 pages, and 4,000 is it? Yeah, I mean.
That's the scrub.
And that's the scrub. You should see the OMAP 5 one before the OMAP 5 got. I think you can still get the spec on the web. That must be closer to 10,000. Most vendors, more than half, require you to sign NDAs and have special customer CDAs and whatever before you can even look at anything other than a fairly sort of innocent data sheet that just describes the functionality of the chip. So our requirement for 96Boards compliance is that you provide enough information to enable developers to program the functionality on the SOC. The reality is that doesn't, on the board, the reality is that doesn't mean you're going to get a full spec of every SOC. We are requiring the schematics are made available for every board under a Creative Commons share-alike license. Interestingly, we are not requiring that manufacturing information be made available. And there's a good reason for that. If you think about something like building microcontroller boards or Arduino, where you can actually basically, if you had the manufacturing information, you could kind of, and makers do, you can make your own version with a toaster oven and a soldering iron. You can't do that anymore, not with 400-pin SOCs and PMICs and impedance match lines and high speeds. So the developers of boards are actually investing in the design of the board, and as long as they're spec compliant, we feel they should own that design. And if somebody else wants to build a board to the same spec, well, they've got the schematics, but they're going to have to invest in the layout and the design of the board and making sure it actually works and tests and quality and so on. And we don't see why that if somebody's investing in the design of one of these boards, another company can just come along and take all the manufacturing information and just build it for free. That doesn't seem fair. So we're requiring the schematics to be open, but not the actual board manufacturing data. If somebody wants to make the board manufacturing data open, that's fine. It's up to them.
That it's actually needed for, if you want to call it open source hardware, you need that as well. So it's not.
Depends on your definition of open source hardware.
There's a definition.
Yeah. Well, there are several of them. You look at OCP, you look at, there's several of them. OCP have one. So it doesn't actually make sense. Well, does it make sense? If that is your definition of open source hardware, that all the manufacturing data must be made available, then these are not going to necessarily be open source hardware under that definition.
Do we have any open source hardware lined up by that definition?
If a board vendor wants to make the manufacturing information available, we're not. That's up to them.
No, I mean out of the ones you're aware of that are coming.
Not that I'm aware of. But so my question in answer to that is, why would you want that? What can you do with it?
Well,
actually verifying that the schematics really are what you've got.
Work out why it doesn't work.
Well, you can assume that, so you can require that the schematics reflect the actual board, right? But I was only I wasn't being difficult in my question. I think what we are, there are two types of board. Historically, there's been very good reason to make boards completely open for a number of reasons, right, in terms of manufacturing information and data. One is for the reason that you say, that it helps you to be able to look at if the schematic doesn't match or doesn't appear to match the functionality, have they got it actually right? But it's more about being able to make a derivative of the board yourself very easily, right? So if you want to create a derivative of an Arduino with without surface mount components or whatever, then it's relatively easy to do so, and that's a good thing, or could be seen as a good thing. That's really not feasible or possible with these kind of SoCs anymore. You need specialist equipment not only to design the boards, but you also need specialist equipment to manufacture them. And
but if you have them, I mean, there are lots of companies that have that equipment.
Yeah, there are.
And if all they need is an extra Ethernet connector, then they can take an open source hardware.
But if they've got all that equipment, then they've got the design capability to take the schematics and do it themselves. And do you really think it's fair for the company that invested in designing that board in the first place?
Decision whether they want to enable that.
It
like
is.
for an SoC manufacturer, it would be very nice if as many people as possible could use that SoC.
Well, actually, one of the
cheaply as possible.
so here's an interesting thing. One of the companies who's their business model is basically to design these boards for free, because they actually don't make any money on the board. They make money from companies coming to them and saying, well, I don't like this, I want an Ethernet connector on for this product I've got, and then that's where they make their money. It's a business decision. Come on, ask some software questions so I can stop talking.
Another question for George. So I think Linaro has the opportunity here, because there's been lots of communities around certain boards, and it's all one SoC or one family of SoCs, one vendor. What's unique here is that we're trying to do something across vendors. So what can we learn from the existing communities? What are the best things that have been done? What are the pain points? And I can share one recent experience on Project Ara. Pain point of something across vendors is flashing tools. See, they're typically Windows based. They're all different. One vendor supports flashing Android sparse format images, except they changed the sparse format. Another vendor can do partitioning, but only 3-letter labels.
But you're not going to specify a entry point and bootloader scheme. What difference does it make?
Well, I think if you can commonize the front end tool and have different back ends and be able to build a database of what different parts, how they operate, and have plugins or something would be a path to something more usable and less ramp up time for new boards.
Is there going to be a roadmap for when components will be upstream? So whether it be kernel, bootloader, etc., so the community has some form of understanding of, okay, we need to carry these patches temporarily for 2 months tops, etc., and we can actually hold people accountable for why they're not pushing stuff upstream.
Is there ever a roadmap for what's going upstream?
Just
It's unpredictable.
I mean, that's how you have to go forward.
Is there a plan?
I mean,
Yeah, I mean, I'm not.
it's going to vary by SoC, right? For different boards, it's going to have a different plan.
Turn it around the other way. When this project started, one of the points was anyone doing a board, both embedded and enterprise, but that SoC vendor is on the hook to upstream everything, right? That's one of the points that George is making going in. Everybody knows if you do a board, the requirement is that it's open, that you have specs, that you upstream code. So what we can do in distros in particular, actually, is we can bias things now a little bit, and we can hopefully get to a point where we have a really good story around these boards, because supposedly everything's going to be upstreamed, and they're going to be, working on that as a requirement to do these boards. So those boards out there that are not part of this project, that are not doing the right thing, one would hope, if the universe plays out, probably won't go this way, but it'd be nice if it did, right? Then you can show people. The purpose here could be that you show people how they should be operating by having this kind of managed experience in which people are required to upstream things as part of the project.
Yeah, encourage people to do it right.
Well, you're actually mandating it, which is even better than encouraging.
We're not
Except
mandating
the
it
first
yet.
example is a bad example already because it's not upstream.
You can't upstream something. You can't announce something that's brand new that no one's seen and have it upstream on the first day.
Why not?
Yes, you can.
Yes, you can.
can.
There are lots of precedents for
Intel.
that.
Yeah, Intel upstreamed the support for the flash hard drives 5 years before the first hardware came out.
And the BeagleBoard X15 went in, 6 months before it was announced, so you can do it.
We thought it was better to get the process underway than wait a year while we upstreamed it. So
You don't have to wait a year. You can do them in parallel. It's not exclusive either. Or it happens in parallel.
well, yes, but you can't have it both ways, right? You can't release it and not have it upstream and release it and have it upstream. So either you wait until it's upstream and then you release it, or you release it early while you're going through the process of upstreaming support. The goal here is to have upstream support for these boards. That's a goal. And if we waited until the first one was, we would not be able to get this program started as soon as we have.
I think what's confusing is whether it's a goal or a requirement.
Yeah.
Which should it be?
It should be a requirement.
You can make
In what time period? So it's, that's very good input. What should we say? That within a year, within 6 months?
So I think a good compromise would be, of course you can bring out a board as soon as you want, but you don't get the 96Boards stamp before everything except for the GPUs upstream. And at some point we will add the GPU once we have a sufficient precedence for people having upstream GPU support.
But what is really everything?
Yeah.
Well, everything would mean that there's no kernel tree in Linaro that has all the remaining patches anymore, because as I understand it, you plan to have one kernel tree in Linaro that has all the patches for all the boards.
You always
Once
have
that
something else though.
I think you could do better with a kind of bronze, silver, gold idea, where you have a bronze board which works, a silver board which is upstream to a certain standard,
We
and
actually
gold where you get everything.
Yeah, that's a good idea. We
Yeah.
talked about that one day. You can have bronze that basically if it boots to the UART from the mainline kernel, you get your bronze stamp. If it's everything except the GPU, you get your gold stamp. So if you do
Silver.
Yeah, if you do GPU as well, we give you some very strong
Platinum.
So just how big is the patch set for the Huggy board for now?
The defined patch set, because the original 3.10 kernel was based on the Linaro vendor kernel, so that has 1,000 Linaro patches on it, which is mainly config twiddling. Mainline boots with 3 patches to UART, and it's all designware or ARM IP, so it's not that hard to get things working. So with 3 patches, which is basically device tree, you get mainline booting. And
clock driver is the main one.
What?
The clock driver is the main one, I think.
The clock driver, the rest is all standard IP, so it's looking good.
No, I mean looking specifically at this one, you know, okay, so we've had a demo this morning using Debian, which of course it would be absolutely awesome to make sure that all those fixes go in before we do the Jessie release. Just trying to get an idea of how much effort that's going to be before I go to our team and say, guys, we've got all this stuff we need to shove in. No, don't ask any questions.
Things like the DRM driver for HDMI need to go upstream. So that 318 patch set is relatively big. Maybe not in amount of patches, but it has a number of drivers. So, but the basic serial booting, that's 3 patches. But it's not. I don't think you will get those into Debian. Those patches.
It is a lot smaller than a lot of vendors.
Yes.
Yeah. So usually what we had when I was working at IBM, support for new hardware was considered upstream at the time when every new patch that was done was making it into the next merge window. So we always had a backlog of patches, but we didn't have any patches that stayed around for half a year.
I suppose it'd be, would be reasonable to say a requirement prior to releasing the board is to have patches submitted upstream, not necessarily accepted, but at least it's out there for review. And if you want to work on it, whether it be a distro or whoever, it's easy to identify the patch set and work with that with your distro kernel, rather than necessarily mandating, okay, it has to be merged upstream. The patches have been submitted upstream, and the community can get the message that, okay, these people are serious about making sure that it's all working upstream. They've submitted the patches. It's a work in progress, and upstream acceptance is going to go at it whatever pace it is.
So who do we expect to do this board enabled work, such like getting HDMI audio working?
It's a Linaro, it's a HiSilicon, someone else?
It will be a combination. So there's for example, the example you've just given, the HDMI audio. The HDMI chip used on this board is DSI to HDMI chip from Analog Devices. In discussions, and one of the reasons the chip was chosen was that they are committed to putting upstream support in place for that chip. So that is a goal, and in that case it will be a combination of Analog Devices for their chip and the driver for their chip, and then on the SoC side, a combination of HiSilicon and the Linaro landing team to get the SoC support upstream for the DSI side.
That's the kernel, and what is actually considered upstream for UEFI? Is that Tiano Core, so complete high key support in Tiano Core, or in the Linaro Tiano Core board overlay, or something else? Because it's not a simple question when you talk about UEFI, what is upstream?
Well, the same is true of the ARM trusted firmware. I mean, in both cases, there's little upstream community.
So what is the criteria for upstream for the bootloader? For U-boot, it's simple. It's that U-boot git dengstry. But for UEFI, Tiano Core has no board support, right, for ARM?
Yes, they do.
They do?
They do. So we've got, there's not very good. Beaglebone, or sorry, Beagleboard, the original Beagleboard is an upstream Tiano Core. I've talked to the Tiano Core folks. They're totally cool. Well, at least the ones I talked to are okay with board support in there. And I think that it's technically and socially it's the right thing to do.
Okay. Juno is also there.
Is that?
Juno board.
Juno is an upstream as well.
Well, I've also heard that the Beagleboard should be ripped out.
Well, possibly. But it's the right thing to do. Doing board support in mainline Tiano Core is the right thing to do, so that should be our goal. Regardless of what the requirements are for the program, that should be what we shoot for. Same thing, I think we should have board support in ARM trusted firmware. My ARM friends may disagree with me, but I think that's important.
The flashing tools, do we actually have any, and there's D, which is a framework for flashing things, but only incredibly slowly via JTAG. I don't know if there's anything better that's free that people actually use in the Linux world. So we have to write something.
For flashing tools, which, I mean, there's two sides of it, or two parts to this. One is, of course, getting the bare image into Flash, which includes ARM-trusted firmware and everything. And the second one is the interface for loading a kernel to boot a distribution. It sounds like we've got problems on both sides right now.
So I think there's been great strides in the bootloader to kernel side of it, and that's in fairly decent shape.
Okay.
Even U-boot. But like, how do you get ARM-trusted firmware onto boards? Or how do you update components of ARM-trusted firmware?
Over JTAG, is there anything?
ROM loader.
I don't know.
The boards do other things?
But
Most SoCs have ROM loaders.
Exactly.
For HKG, if you erase it, it goes to serial, waits for you to upload something to memory, and then you couldn't upload the bootloader. So
But
they were unbrickable. You shouldn't need JTAG, but every SoC has a different ROM loader in a different way. I mean, TI has
do we have something
Ethernet
that
over
talks
USB.
the protocols of those things, or do we have to do that?
On EFI, there's a way to do it with a EFI update tool.
at least for HKG, there will be a tool that's open to do that.
Okay.
Now, whether it's a good tool or not.
It's on GitHub already.
Yeah.
It's called Burn Boot.
But still, it's unique to HKG
Yes.
board. It's not a common tool.
Well, I guess everything's going to have to talk whatever protocol it is for the in shit. That's the
So,
part.
so I think what you have to do is you have to load.
We just need to make something that speaks. I suppose the problem is it hard to do something that speaks to more than one device because there isn't a kind of any negotiation, right? It just starts. And you have to send
Well,
it
I think you want to load something that then implements a common protocol.
Yeah.
Right? And then you're only implementing load to RAM and run using the boot ROM protocol.
So is this a requirement then, we're saying, that to get a 96Boards standard, you at least provide an open documentation of how to do the initial boot?
Yeah, I guess we could require
It-
docs would be reasonable.
Describe the protocol for the ROM loader.
Certainly, I think whatever tools we get should be open and just so that we can implement something common, right? The vendor tool should be open, or the documentation for it, for the protocol, needs to be open.
But that's presumably not in the spec. At the moment, we don't require that they document their protocol, or what?
I'm going to provide a contrary view on this one. We are talking about board bring up here, and us as engineers and those of us who work on firmware, we really like things to be the same. The vast majority of users of these boards are not going to be working on firmware. They're going to be working on the kernel. They want to get up into the kernel. They want to get a real environment there. Yes, we have to have open tools. Yes, we have to have a way to get new firmware on each one of these boards. I don't think we need to spend an exorbitant amount of energy wringing our hands about can we have the same tool for doing initial flash load in every single one of these boards, when the goal is to get to the point where we've got common bootloader, where we've got standard interfaces for either U-boot or UEFI, where we know how to get a distribution onto the box.
But isn't users bricking their boards a common problem?
Only if we're messing with the stuff that he said, that we don't need to worry about.
We're not saying it should be a common tool.
No,
We're saying we're saying that whatever is required should be at least open so we know what we've got to do.
Okay.
Yeah, I think that's all that's required.
So there needs to be sort of a line here, and on one half of the line there's stuff that most users won't touch, but some users need to be able to update, right? And that's probably UEFI or U-boot. And on the other side, you've got the distro, the kernel, the distro, etc. Which side of the line does DT fall on? Which side of the line does your ACPI stuff fall in? That becomes a question.
Well, because, I mean, certainly we want to. I'd like to hope that on these boards we don't have we need an ACPI quirk because the ACPI tables are broken. We should be able to fix the firmware to. The solution to that should be, here's the firmware, update your firmware, we fix the bug in ACPI tables, rather than add quirks to the kernel to work around this firmware that we can't or is too hard to change.
At which point you need a relatively simple firmware update.
Right.
If you're updating that stuff, you use EFI capsule update. Runtime update, standardized, one way to do it on every distro from a booted running system. That applies for ACPI, and if you need to do development updates to ACPI tables, there's already support in the kernel for having them in an RD and overlaying them at runtime. So that's what you do during development, then you put it into an EFI update and you flash it as a capsule, and there's one way to do it.
EFI updates don't necessarily replace the original, they overlay them, is that right? Or is there a
No,
choice?
there's a bit of flexibility there, but usually you replace the whole thing.
There's a catch though, because I don't think UEFI and ACPI are software requirements for the spec.
Yeah.
But certainly not for the
Not consumer one.
consumer one.
Right.
I'm somewhat biased about the enterprise side
Yeah,
of it,
we
because
know.
there's the enterprise board as well, right?
Yeah. So how do we standardize the overlays for add-on boards? Because it would be bad if you design an add-on board for the high-speed connector or for the low-speed connector, and then it only works on half the boards because the DT overlay doesn't work on some of them.
Are the boards discoverable? Is there a discovery mechanism for add-on boards?
It's an interesting question. We have discussed whether we should require, for example, an I2C area for doing that. We haven't spec'd it from a hardware or software point of view, but we could do.
Because I2C would be nice because you can put both an SSDT in there for ACPI or an overlay for the DT things.
It's really, really nice. If you take a look at Gigabyte Black, to Gigabyte, it starts stuff like that, and nobody does it anymore.
I know.
And the same will happen.
Right after the software cooking quit.
So while we're on the topic of hardware, oh sorry, go ahead. Okay, so while we're on the topic of hardware, one question I had is if there's a plan to provide either required or optional specifications for doing fine-grained power measurements on these boards. So I've looked at the spec from like a month ago, and there was, I would describe it as a weak language in there about being able to maybe instrument just at the battery or the DC input, and that's it. But there's a lot of people who are interested in being able to get fine-grained power measurements out of this.
This was something in the last session that came up, and I think there's probably agreement that it's needed to specify optional stuff that if you implement it, then you should do it this way, so that we don't have it implemented 10 different ways.
Okay, I agree with that completely.
Can we implement?
So submit your proposals to the spec.
I'll resubmit them.
You can look at mine too that have already been submitted.
Can we require links where you can stick a sense resistor if there's a problem with the PMIC not really supporting it? So that's
There's a lot of caveats, right?
The spec at the moment, there's two problems, and we did cover this briefly in the last one, so I'll be quick. The spec requires at least one sense resistor, which you can populate with a 0 ohm link if you wish to, and the user can then change it and put a 2-pin header. We've also suggested that there's support for the ARM Energy probe, which is doing exactly that with 3, and then Bay Libre in France also have a proposal for which we've made the spec compatible to if you want to use that. The problem that turned out on the high keyboard, and we've actually seen this now on other boards in design, is that what we'd like to do is sort of spec, you've got to put at least 3 or 4 on the major power rails coming out to the PMIC. You don't want to tend to put too much because these actually take up quite a lot of space because each one of them is a 2-pin 0.1 inch header. But what we wanted to do was say the major power supply rails for the RAM and for the coming out of the PMIC for the SoC. But it turns out that most PMICs are extremely sensitive to having anything downstream of their voltage output, and putting even as a low-speed sense resistor was strongly recommended by the SoC designers that we did not do that. So we on the high keyboard we've actually got 3. We've got one for the power supply going into the PMIC, one for the kind of 5-volt rails going to everywhere else for things like HDMI and USB, and one for the whole board power consumption. But I'm sure somebody will, I mean, if you look at what the Chrome team do for Chrome devices, they've defined a full kind of header interface which they automate, which does have a lot of power management capability, and they do actually require you to put quite a lot of expensive circuitry onto a Chrome board that they can then hook up to their automated power measurement systems. So you can do it, but you add quite a lot of cost.
I think that you can completely avoid the whole issue of trying to standardize on one connector that plugs into the ARM Energy Pro. I mean, we could just specify having 0 resistors on there of a certain size, like 0802 S&T parts or something.
It's going to be bigger than that. Some of these, you're putting quite a lot of power through these rails.
Can't you have voltage drop problems even with 0 ohm resistors?
You can, but there's a lot of tricks. I mean, I'm not talking about like some really easy little project that someone just buys a resistor Radio Shack and puts it on there, right? But there are things, if we got margin information, like voltage drop margins that are tolerable, we can get that information from the PMIC or AP manufacturer. That'd be really helpful. I mean, it would free up an area where we have a big deficiency today, which is the ability to really measure fine-grained power on the boards that we're writing software for.
It's not uncommon to have a footprint with a copper link between the
Right,
two.
a cut trace.
Feel free to cut your trace. If you want to measure it, do it.
So going back to boot story, so we're going to end up with the high key's got UEFI or U-boot as well. Will has, Will has, yeah. If we end up with more boards that are only coming out with U-boot, not UEFI, or we at least, we have massive discussions on the cross-distro list over the last couple of years about different U-boot standards and whatever. Are we going to make the board or the board vendors follow what we agreed to make sure that a standard distro install doesn't need to fight against a broken vendor U-boot?
So there's been a lot of work there in U-boot to define what that is, and there's standard config headers now, basically for distros. So I think on the U-boot side, that's made a lot of progress.
So to summarize, the requirement for bootloader, it's either U-boot or UEFI, or can it be something else?
It can be whatever you want to write. But
Cool. No, but that means there is no requirement for bootloader. Just need to somehow load, or
The spec, as I read it, had a requirement to provide one, but not a requirement to have one burned in, right?
I'm not
So
sure
they have to
offhand.
provide the software, but not necessarily on the board.
The enterprise spec requires.
Okay, so the spec says boot architecture, open source implementations are strongly recommended, must have support for a bootloader such as U-boot FDT, UEFI ACPI, UEFI FDT, optional support for a secure execution environment, support for ARM trusted firmware recommended, including PSCI APIs optional.
So that implies that they can ship me
a closed source UEFI.
Yeah.
Yeah, it's not prescriptive. Now, again, this is kind of one of the purposes of the steering committee, that if we get enough input that here's what we should mandate, we can do that. But you've got to think about, you don't want to prevent the Chrome guys using Coreboot because that's what they use for all of their stuff. What I would like to see is these boards used as reference implementations of any bootloader. So the Coreboot guys provide a reference Coreboot port that then other people who want to do Coreboot on their boards, they have a nice open source reference that they can put onto the next one. Same with ARM trusted firmware and UEFI. Same with U-boot. That here are the reference examples. Once we've got 2 or 3 of them, then hopefully a lot of these inconsistencies and differences will resolve themselves, because people will use the same code, because it'll be easy to do so.
So the number one concern I have as a distro dude isn't that we all need to do what John says, but that
If you just would, it'd be much easier.
It's not gonna happen. But that boards that literally ship with no firmware on the board require us to build a custom installer for every single one of them. So I'm gonna have 96 installers. Whereas if you burn on a U-boot or a fastboot or a core boot or EFI and ACPI or EFI and DT, I don't care. If something's burned on there that can get me the disk, then I can have one installer that installs on all of them.
Right, there's probably a whole section on out-of-the-box experience of what needs to be there.
Yeah, because out of the box experience typically on ARM boards, it's always been kind of crappy.
Or varied.
Or it's good if we build a custom installer for you that just works, but we've got to build 70 of them, and that really sucks.
Or two. Because this is the first board, right? So you learn from this one, and you say, okay, well, this is awesome. Here's how we'd like to do it differently next time, and then you can expand and add things to the spec for the next board, right? This ship has sailed now today. But
You don't say.
But there'll be another ship, and then that one you can have more requirements.
Well, some question, yeah, is how much more restrictive do we want to make this?
How
maybe
often
some-
do you plan to update the spec? And once you have a version of the spec, when do you say a new version is out and you can no longer?
That way you don't have add-ons that take you to that.
Well,
Okay, so that's up to the steering committee.
That could be a minor upgrade for requiring a specific bootloader interface. When you say, well, we have version 101 that requires to put the kernel in a specific place on the disk and require the bootloader to load it from that place. And then you can upgrade the firmware to match the spec. It doesn't even have to change the hardware.
Or mandate fast boot.
Yeah, I mean, as with, there's going to be a pipeline of the boards over time, and the boards that come out first, it's going to be harder and harder to try to get new things out of, put new requirements on the boards that are already out. But what we can do, especially with UEFI, is relatively easy because we can point at a spec, we know this is what we expect. And we can start, that stuff that we can talk about probably at the steering committee level of, do we start adding that to the requirement? Same thing with U-boot. There's been a lot of work done to standardize the interface to U-boot. Can we start pulling out some of that language or point at documents in the U-boot directory that said, you need to be able to boot this way? And that's a worthwhile thing that as we move along on this program to start pulling that stuff in. We may not be able to do it now because it knocks a bunch of SOCs and a bunch of possible boards out of the market because they can't do it right away. But it's something that we can shoot for as the project goes on.
Should be part of the gold qualification,
Yeah.
not the bronze.
So is there some thought towards like versioning the compliance, right? Because that's one way of handling adding more strict stuff later on, where you could say, yeah, your 96 boards compliant today, but there will be 96 boards compliance v2 in 2 years, and then kind of gives everyone a nice reset, to say that there is some new, maybe stricter stuff that you added.
You can probably only add requirements when you have a future board, right? The board that's made today is compliant. You can't come back and say, oh, you guys
That's
should
the point,
ship
is that
this,
the
right?
board that's made today is v1 compliant,
Correct.
right? And yeah, but you want to demarcate that stuff so it's fair to
Right.
everyone.
But you want to tell someone we're going to rep the spec in this period of time. New boards that begin design after this date need to conform to, and that's the way to do it. Right?
And a lot of end users won't care that much, but there will be some that do, and it'll be nice if there's infrastructure in place for them to see, like, oh, this is like from the early days of the spec, and maybe won't do everything I want.
Well,
Yeah.
what it means, and what I think is particularly interesting on this project is it lets us define, these are not general purpose boards in terms of
bootloader and an open source kernel tree and so on. But every vendor's not going to be the same. And if a vendor is horrible about this and really bad, well then we basically won't give them certification until they improve it. But we took the choice that we didn't want to be too prescriptive to start with. We wanted to try and let the market speak to a certain extent. And your input is really useful, because if you start commenting on the forum, I'm not going to buy this board because it doesn't have an open bootloader, that's a perfectly valid thing to put on the forum. And that kind of message will get out if you say, I represent this distribution, I don't want to support this board because I don't have enough information. That's useful information back to the board vendor, right?
So from a software perspective, what are your aspirations? What do you want to see the community do with these boards?
Cool stuff.
Everything.
Obviously. Create an even faster math library.
It's interesting, isn't it, that we're debating the features of firmware and so on a board that's 10 times cheaper than anything we could have bought yesterday. So, you know, it just, there's a lot has happened in 24 hours there, right? I mean, it's good progress.
Imagine trying to have to buy 10,000 vaxes to get that knowledge, and then find a place to plug them in. Wouldn't fit your briefcase.
Probably up to 20 pages on the forums already.
Can you get me EFI on that vax?
Any last comments?
Are any bulk buy restrictions? Bulk buy restrictions?
That would be up to the board manufacturer and distributors, I guess. All right.
How
Well,
many different boards do we currently know of that are likely to be coming through, say, in the next 12 months?
My guess when we started this was 5. My current guess is 10 this year.
Awesome.
Are they all V8 boards or any V7?
Some V7.
So
Mostly V8.
There's been no questions there about common denominators and boot strategies between V7 and V8.
I'm afraid we're out of time.
thanks, everyone.
We have a great opportunity to rationalise the V7 world.
So actually,
Yeah, we've been trying to do that for
So I will ask the question I have heard a couple of times. So why V7? There's lots of V7s out there already.
Because a number of the members, when we talked about this program, said we really like this and we'd like to put our V7 chips into this program as well.
But really cheap.
And we also think that as we move towards IoT devices that kind of are bigger than microcontrollers but smaller than 64-bit chips, there is going to be around things like A5, A7. There's going to be a low-end, low-cost Linux market, and having development platforms for those chips are important.
Are they all V7A?
V7A would be a very good requirement, yes. We're not going to support V6.
No, I mean R. Or
O and sorry,
V7R.
Cortex R or Cortex O, V7R.
Your argument there then may be that in the V7A world that you actually prefer thumb to ARM for your bootloader code, because then potentially you could share some libraries with your M-class power controllers and everything else. So you may find there's some silly reasons, but I do assume it's an A-class
The intention
for the main process, application process.
All right. I think we're out of time. Thanks, everyone.